Hello and welcome everyone. So in this video we are trying to use graph database to improve the rack system, okay, instead of document database, okay. And also in this graph database, for example Neo4j will also include the vector embeddings so that it can further improve the overall performance of the system, okay. As we discussed, we will be using the Neo4j vector database, okay. So in general what we are going to do, okay, like for example in a knowledge graph, which is the complete documentation, okay, of our input database, I would say, okay, which will be split and converted into a graph, like adjacent nodes will be created and stored, okay. So in this graph, okay, for every node, the information what we are holding will also be having the vectors embeddings, okay. Okay, like for example you can take any vector embedding like clip from OpenAI model, you can take, or some other model you can take to extract the embeddings, okay. We'll see very soon now, okay, to do so, okay. So the overall idea is whenever you get a user query, okay, so for example latest tech news, okay, so it will come to the rack system, okay, and internally it will go to the vector embeddings, okay, so of every nodes or relationship between the nodes, okay, and properties, okay. And then we'll try to understand how different they are in the embedding space, okay. Along with that, we also have the benefit of connected nodes and their relationship, so that will also enhance the processing time. It will take less time, as well as the overall quality of the response will be far better than using only the rack system, okay. That's the reason we are trying to do so. And again we need some extra LLM or another model which can extract the embeddings as an extra step here in order to complete this task, okay. So let's get started, okay. So this is my notebook, Colab, okay, Google Colab. Let me try to zoom it a bit. Wait, yes, okay. So I guess hope it is visible, okay. So now in order to do this activity, I am using majorly three things, okay. First is LangChain, okay. Second is Neo4j vector database, sorry, graph database, okay, which can also store the vector embeddings as well, okay. And also the Hugging Face transformer library for loading the models, okay, in order to do the embedding extraction, etc., okay. Great. So as a step one, we are trying to install the required dependency here, like for example LangChain community and LangChain core. I already run it in order to minimize the processing time. So let me okay, hide the output. Sorry. Yeah. So again we need a Hugging Face and experimental setup, okay. Again I will try minimizing it to speed up the process. Again as we discussed, we also need a transformer and Neo4j stuff, okay, here in order to complete the experiment, okay. Before going, I just want to show you here, this is the Neo4j instance where we have created a free instance over here. And if you can see here, we have the number of nodes as 29 and the relationships between the nodes as 68, okay. Just let me show you, just to complete the overall process. Wait for a minute, it will load. Yes, loading. Okay, yes, great. Click over here, you can see all the nodes available, okay. So if you zoom it a bit, tick, 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 yes, so you can read the node, the names like are available, Lisa, Wang, etc., okay. So these are the things you can see, and you can see the relationship between them also, okay. Just for discussion, okay, it's little slow, yes, but it will come, yes. Like for example okay, transformer architecture, okay, in topics, some another node like foundations of etc., okay. So this is the relation between them is in topic, okay. Over here transformer and David Johnson, I guess the relation is published, okay. Okay, this guy, okay, publish the transformer architecture, like that, okay. So it's like this. So this is the overall graph, and now for every graph node we will try to extract the embeddings as well, and we'll try to use these while we are generating the response using the rack system, okay. Let's come back to our notebook, okay. So yeah, so we were installing the dependencies done, and then we are importing all the things. For example, neo4j graph things we need. Okay, we also need the transformers. Okay, LLM graph we need. Okay, we also need pipeline to create the model here in order to use, and this is to interact with the model, sorry, interact with the graph database in a safer query language. Okay, let's get started. Okay, so to start with, okay, in order to create a pipeline, or in order to use any LLM model, we need okay, I am using Hugging Face. Okay, so you have to pass your API key. Okay, go to the Hugging Face access token, then create if it is not there, or take it if it is already there and paste it, or you can also store somewhere like in the key. Okay, or like here in that case, or you can store here over here as a environment file. Okay, perfect. So as an example, I am loading the model llama 3.2 3 billion parameter model. Okay, you can take a bigger, more better model as well. So this is a moderate one, so it's not so mini, or it's not so huge, so it's in between, so I thought to take this one. But of course the performance will improve if you take a bigger model, like 10 or 11 billion parameter or 70 billion parameter. Okay, that is something you can make experiment. But here the overall goal is to show the pipeline how the setup will be. Okay, for that reason I'm just using one model. Okay, great. Okay, this is the model, and here this is a pipeline of the Hugging Face, wherein we have to provide, it's a built-in instruction. Okay, syntax, wherein it will accept what kind of task we are looking for the model should do. Okay, so we want the text generation. Okay, and what's the model type? It's a model name we have to provide, and the type, and then auto. Okay, mapping is auto. Okay, perfect. Device, either it is CPU or GPU, it will check. Perfect. So good, then pass it to the Hugging Face pipeline, the things which we created just now. It will load the model parameters. Usually it is a heavy file. For example, around 5 GB, along with it supported files also will be available, which will help us to infer the data. Perfect. Okay, like we discussed, device is set to CUDA because it's a heavy model, so it will require GPU to make a run fast. Okay, great. Then here I just commented my credentials. Okay, your username, password. Okay, at the time when you are creating the new instance. Okay, that time for example, here if you go and create button here down bottom right. Okay, it will give you the option. Okay, at the time of creation, it will also show you the your user ID, password, and URI in order to connect it. Okay, those things you can use it here, or keep it in a secret way and use it. Okay, I already done, so I just make it hidden here, just to avoid showcasing or revealing the password. Perfect. So take these credentials of the Neo4j database and then pass it here in order to connect it. Okay, great. So we connected. Okay, after connection, okay, here at this time we are trying to load the data. Okay, so I just use the data over here, synthetic. Okay, articles. Okay, these articles will be loaded as a row. Okay, okay, it's like this. Load the CSV with header like this. Okay, from this location. Okay, and the name of this CSV now will be referred as row. Okay, now terminated between the files line terminator we are using as semicolon. Okay, now in the like we discussed in the last session. Okay, the merge will basically create a new node if it is not there, otherwise it will search for the node if it's already there. Okay, so the alias for the node is a. Okay, and the node name is article. Okay, and the article name or the title we are filling from the row. Okay, which is coming from here. Okay, row dot title is equal to title here. So now we are creating a new node, name as article, having title as coming from the CSV file, which is row dot title. Okay, now also at the time of your creation you also need to put furthermore values here. For example, properties, I would say a is a node alias we given here, which is article now, So instead of writing article, we can say a dot abstract, okay, take it fill by the input row dot abstract. In the same way, publication also you can say from this after converting to a date format. Perfect. Now we are writing a for loop. Okay, every time go into the author directory, give a name as researchers. Okay, researcher, give a name over here from here, and also add a relationship between them. Okay, researcher P is for researcher here. Okay, published A. Okay, what is A? A is nothing but article. Okay, researcher P, publish a for article. Okay, so in that way, for every person or researcher within the CSV, we are doing this operation. Okay, in the same way, there is one more for loop here wherein we are taking every topic. For every topic, okay, what we are doing, okay, take another alias name, okay, which for topic. Okay, now we are telling a which is again article. Okay, in topics t is for the topic. Okay, this is the relation topic and article relationship is in topic. This article is within this topic. Okay, like that the relations we are providing. Great. So this is the query, and then pass this information to the graph database. It will store this and it will generate the complete data. Okay, and create the graph like we discussed just now. Okay, okay, I think I need to cancel this, connect it. I already run it, so I'm able to see the graph. It will show something like this in topics, etc. will be available here. Okay, it's loading again, but okay. So perfect. So this will create the graph and it will show you all the details. Okay, and then after that we are just checking whether the everything is fine or is there anything not working. You can do the refresh and you can print the schema details. So the number of nodes, property, what are the things it created, how the relationships are being article in topics, topic, etc. These are will be showcased to us, saying that this is the schema we are using to create the graphs. Okay, perfect. So once it is done, okay, as I told, you can also use a dot environment variable okay, in order to load it. Okay, I just commented here my secrets. Okay, instead if you like to keep, you can keep it in the environment. It can load from there to avoid showcasing the secrets. That's also one good way. Okay, just wanted to show you here. Yeah, perfect. Again, we need go here for our model. Okay, I just imported it. Okay, okay, yeah. So this is the model we are doing going to use to extract the embeddings. Okay, please remember this is a very tiny or not so big model, so the response will be not so good, but you have the option to change it. Instead of this model, you can take a more better from chat OpenAI or from another bigger house like from Google, another Gamma or more better models you can take it. Okay, but for our experimentation I just want to keep a minimalistic model. That's why I just use it this model for embedding extraction. Perfect. So we just took cohere. Okay, from cohere I'm taking a model name as this, and this will be utilized later for embedding extraction. Great. So now if you see over here we are trying to like I just commented here, you can use the other one OpenAI as well. Okay, which I am not using because of compute. Yeah, great. Since this is just an experiment for sure. Yeah, great. So now we have an framework. Okay, over here neo4j vectors will be extracted from the existing graph. Okay, extract the embeddings from the existing graph. Okay, by using this model which we just declare here. Okay, and these are the my credentials to connect. Okay, and node names we can specify, and the properties, like these are the properties only you need to take and extract. If you like to subtract one or add extra, you can do so. Okay, and property name you can say embeddings. Okay, take this and try to run it and it will generate the embeddings. Okay, great. Okay, that is done. Okay, like we discussed, you have to remember you also need to have the cohere API in order to use cohere models. Okay, if you like to use something else outside the cohere, you can also feel free to do so. Okay, so I just use this model for my experimentation as an LLM model. Okay, great. Okay, so that is done. Now this is the time, okay, in order to provide the model, and also we have to create the vector QA chain. Okay, question answer chain. Okay, so retrieval QA, okay, from a chain. Okay, which model you are using? Okay, just provide. I'm using coherent LLM model, which is command R plus. Okay, it's a not so recent, but should work for us, okay, in this example. And also we are telling vector indexes also should be utilized at the time of question answer. Okay, great. So this will ensure we have the vector QA, which is kind of I would say interface, which has all the information available within it, like which model to use, what to do. Okay, and QA, it has to perform, okay, all this information by using embeddings. It has to do this information we have given. Okay, once it is given, okay, this QA, now we can take it, this vector interface, we can take it in order to make queries from the vector database, sorry, from the Neo4j database, which is a graph database. Okay, so now here what we are telling, qa.invoke. Okay, what we are invoking, a query we are passing over here, which article discusses how AI might affect our daily life, okay, etc. Okay, so this is our query, we are passing it, and it will respond us. Okay, in order to respond this query, embeddings will be extracted, and then internally it will pass it, okay, to the model in order to understand the, okay, let me show you. Okay, this query will be there. Okay, this query will be passed to this model. Okay, and this guy, before doing anything, okay, it will extract the embeddings. Okay, and then LLM model will take it and try to understand what to do next. Okay, so that's how it works. Okay, and now you see the response here. Okay, these are the article 1, 2 and 3 which discusses the AI. For example, here the social implications of advanced AI, etc. Okay, AI and the privacy. Okay, the impact of AI on employment, etc. Okay, these are the places. Not so bad result. It still is a good response, I would say, with the given available model we able to generate. Okay, perfect. Okay, I think this is not required, but yeah, this model is not required. Okay, so yeah, so it's up to you if you like to use another pipeline, but I think it's okay, you can skip this part. Perfect. So here now we can also do further processing. Okay, by providing the prompt here. Okay, this is another way. First, what we have done so far, we have created a vector question answer chain here. Okay, which actually take the input question and try to search for the responses in the vector embeddings. Okay, and then now yes, now we are loading another model, which is llama 3.2 3 billion parameter. Okay, this parameter model we are taking. Okay, and creating another graph based search. Okay, okay, this time there is no vectors. Okay, vector embedding based search we have done already over here. Okay, now this time, okay, taking this model and trying to search by using the only graph. Okay, so create a pipeline, okay, of the Hugging Face and pass it to your Hugging Face pipeline. Okay, and take a simple query here, a prompt we need to pass in order to do so. Okay, for example, here initialize it graph cipher Q&A chain. Okay, with graph base. Okay, so pass one LLM model which we have created, which is llama 3.2, and then pass the graph database connection information and a prompt what you want to do. Okay, prompt is here, generate a cipher query to answer the question. Okay, here please note we are not using the embeddings, we are only passing the graph based query. And if you go one step back, here we are using the vector indexes in order to search. Perfect. Yeah, so yeah, we have connected the chain. Okay, and then like usual you can invoke, okay, chain dot invoke, and ask a question. Okay, like how many articles has published by, I think by is missing, published by Emily Chen. Okay, so you can get the response. Okay, here published, the Emily Chen has published 7 articles. Okay, okay, yeah, in the same way, the difference between the two is it is based upon the LLM model, which extract the your query and try to create from natural language to a cipher query language, and then it will ask and then it will ask the question to the database, and it will get the response. Okay, but before it was only by the vector embedding base. Perfect. Okay, in the same way you can ask further more questions like yeah, one more. Yeah, here, like for example, are there any pair of researchers who published the more than one articles together, etc. Okay, for example, this time the system was not so quite sure. Okay, is giving responses, but I feel not so response, like it's empty and multiple questions it's generating by itself. Response was not so obvious. Okay, I believe it is because of model. Okay, so you can experiment here with a new model and let me know how is the response. Okay, and again over here, like which researchers has collaborated with the most peers. Okay, and the query was not so properly generated, the cipher query here. Okay, so the response was not so good. Okay, like we are unable to determine which pairs, etc. it's telling. Okay, so the in conclusion, I would say there are two ways you can do. Okay, only graph base is not enough, and only embedding base is not enough. Okay, if you want to have the best of the two, okay, you need to combine the two. Okay, like we discussed in the first. Okay, it gives more better and more prominent better responses if you use the vector embeddings along with the graph. Okay, and but again we need to see which model to use. If you use a tiny model, okay, that response will be not so obvious. Okay, not so good. Okay, so but in general, if you moderate a good level of model available with you, then it should work much better than what the rack in all alone do. Okay, so that's the conclusion over here. Okay, thanks for your time, and see you soon in the upcoming video. Yeah, see you, bye.